We're on our new unit class, which is on fractions again, but now we're working on understanding addition and subtraction of fractions. So let's begin. So in the problem on the previous page, why aren't the purple 1/10 strips the same length as the red strips? So since we're doing it on the distance learner, since we're doing it on YouTube, we don't have those purple strips. So we have to remember back from our visual learning that we watched. And if you remember, the purple strips are 1/10. Oops, let me get there we go. Purple strips are the 1/10, and that red strip was the whole. So why aren't they the same length? Well, because one's showing how many pieces they need to make a whole. The red strip represents 10/10, or all of the canoes. And what do the purple strips represent? The purple 1/10 strips represent 7 silver or brown canoes. Which is 7/10. So remember, one's representing the whole and the other is representing each individual canoe. So now we have number 2. Which two fractions are being added below? What is the sum? Well, here we have 2/8, and sum means adding, so we're adding 3/8 because we have 3 of them. So our final answer is 5/8 for the sum. Now, for number 3, we have 2/5 plus 1/5. Well, I see that's 1, 2, 3/5. So our answer is 3/5. This one over here, we have 2/6. We have 1, 2, 6. So our answer is 2/6. So adding our fractions, remember, is pretty easy. All we do is we add our numerators together. Okay, so now for our next one. 3/12 plus 4/12. Well, I see 1, 2, 3, 4, 5, 6, 7 pieces out of 12, 7 12s. Here we have 1, 2, 3, 4, 5, 5/10, which as we see is the same as adding those numerators together. Over here we have 1, 2, 3, 4, 5, 6, so we have 6/12. Number 8 now. Here we have 1, 2, 3, 4, and then down here we have 5, 6. So how many 6 do we have? Well, there are 6, 6, which if we notice on our number line is the same as 1 whole. So either answer would be okay for this one. Over here we have 1, 2, 3, so we have 3/4. Over here we're going to add our numerators. We get 2/3, which we see matches as 1 2/3. Number 11, remember we add our numerators together, so we get 6/8, 6/8. Number 12, add those numerators together, we get 4/4, which maybe you recognize as 1 whole. Number 13, we get, when we add our numerators, 9 12ths. And our last row, we add our numerators together, we get 2/4. Number 15, we add those numerators together, 2 plus 2 equals 4, and then the denominator stays the same. For number 16, remember we add our numerators together, the denominator, that bottom number, stays the same. So now let's head to our next page, those word problem ones. Number 17, using 3 different numerators. So remember, numerators are the top numbers. Write an equation in which 3 fractions, when added, has a sum of 1. Well, here it's telling us we need 3 fractions, so I'm just going to set it up. And it's going to have the sum of 1. So what could that be? Well, we could do 1/2 and 1/2, but our problem here is that's not 3 fractions. That's only 2. So what else could we do? I know. Let's just do 1, 2, 3, because we have 3 different numerators. But now I need to figure out how that would equal 1. So, So let's try something else. Let's just pick 10, because 10's always a nice, easy number to work with. And now we need 3 different numerators. Let's do 1, 2, oops. Oh, and my pen died, so we'll do 1, 2. Now notice, this last one has to equal something, right? So that last one has to equal 7. Why is that? Well, because when we add 1 plus 2, we get 3, and we need this to equal 10 tenths. So our mystery one could be that. Now, there's many, many more answers. There's actually an infinite amount, so that's just the one that we put down. Now, our next one, we have a rope is divided into 8 parts. Draw a picture to show 1/8 plus 3/8 equals 4/8. Well, here we would have a picture of 1/8, and here we would have 3/8. Remember, we do want to try to get them the same size, but I'm now using my finger, and then we see this equals 4/8. Number 19, a bakery sells 9 dozen bagels per day. So a dozen is 12, in case we didn't know. About how many bagels does a bakery sell in a typical week? So remember, a typical week, that means there's 7. And we have this keyword about. So what does about mean? Well, it means it doesn't have to be exact. So we can, if we want, round this to 10, because that's an easy number. So per day, we have 10 times 12 equals 120. And then we need to multiply that by 7, because there's 7 days in a week. So it's going to sell about 840 bagels a week. And if we didn't know that dozen, it's telling us right over here as well. Number 20, what addition problem is shown by the fraction strips below? Well, we have 3/8 here, and we're adding 3/8 right here. So that's our addition problem. And then what does it equal? It equals 6/8. Number 21, Terry ran 1/10 of the distance from school to home. He walked 3/10 more of the distance and then skipped 2/10 more of the distance. What fraction of the distance home does Terry still have to go? So, I'm going to draw a number line or a picture to help me. So Terry ran from school to home. So here we're going to say is school, and here is home. And he ran 1/10 of the distance. So we're going to break this up into tenths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So he ran 1/10 of the distance from school to home. So it looks like he went right here. And that was what? That's a run. He walked 3/10 more of the distance. So that's going to be a 1, 2, 3. So let's say walk. And then skip 2 more of the distance. So that's 1, 2. What fraction of the distance home does he still have to go? Well, he still has to go what? He still has to go 1, 2, 3, 4. He still has to go 4/10 of the distance, because that's what we haven't accounted for with the walking, the skipping, the walking, the skipping, and the running. Now, for our last ones, Jackson said, I'm thinking of 2 fractions that when added have a sum of 1. What 2 fractions could he be thinking of? So we're adding a mystery fraction plus a mystery fraction, and it's going to equal 1. So remember, when it equals 1, what do we know? Well, we know the numerator has to be the same as the denominator. They have to be the same numbers. So here we would have 10/3, which is not the same. Here we would have 4/4, which is the same. Here we would have 6/5, which is not the same. And here we'd have 7/8, which is not the same numerator and denominator. So our only answer is B. 23, Lindsay has 5 red hats, 2 blue hats, and 3 black hats. Which statement is true? 8/10 of the hats are either black or red. So, looks like you have to figure out how many total hats we have first. So here we have 5, 7, 10. So there are 10 total hats. So 5/10 of the hat are red or black. Well, red's 5, black is 3, or 8/10 of the hat are red or black. So if we add those together, we would get 8/10. So it looks like our answer is going to be A, but let's just check the others. 5/3 of the hats are either red or black. Well, that's not true, because red would be 5/10, and black is 3/10, which we just saw up there is 8/10. 5/10 of the hat are red or black. Well, no, because we already showed that's this one. Then 3/10 of the hats are red or black. So our only answer is A. That's it, guys. Good job today.